turbines, although a lot of people don't think so. But the input turbine sound power level is based on field tests that have been done, in this case on the Axioni units, by an independent testing company in Germany. So it's not, we've done this test at some turbines recently done in Texas. I'm very familiar with this test, very accurate test. In the model, in this test, you measure downwind of the turbine. So, simply upwind is going to be a little quieter. But we just say that the noise is going to be in the downwind level in all directions all the time. We don't distinguish between upwind and downwind. We just say it's going to be the downwind sound in all directions. It turns out from field tests that we've done that there isn't a whole lot of directivity to the turbines anyway. It can essentially be ignored. And then in the model, we assume that the ground is moderately absorptive. This absorption ranges from, coefficient ranges from 0 to 1, and we just picked the middle value. Intuitively, you wouldn't think that the ground would have any impact on turbine, but it actually does. And so you wonder, is this, all these assumptions, does that end up giving you an accurate answer? And we've done a number of field tests to check it. So here's one example. This is a project here in New York. We went back and we measured a number of points within the project area, and measured for 2 weeks. We essentially repeated the background survey using the same methodology. And what this chart is showing is all these dots are the actual turbine sound level at this particular house as a function of wind speed. And the mean through all this data scatter is this line. And these red dots are what our model predicted at that house at these different wind speeds. Now these dots are the turbine sound level alone. We put monitors off of the site to get the simultaneous background level, and then we can subtract out the background to get what is just the project doing, and exclude as best we can anything, wind noise to the trees and all. So we're getting real good agreement, and this is using all those same assumptions with the ISO standard, with the 0.5 ground. If we used less ground absorption, we would have some of the points would start rising up here above. And here's a totally different site and totally different turbines out in Wisconsin. Same exact thing. This is the project sound level, and the mean through that over all these wind speeds is in really good agreement. These are just randomly selected points. This happened at every measurement point, 8 to 10 points at each site. And finally, another site down in Texas. This is the project sound level, and this is what the model would predict. In this case, just at 7 millimeters per second, right up there. When the turbine comes on, the level just kind of goes here and sits here at this particular house. So we're confident in the model. So here's the latest plot for this project. The 42 is the 6 dBA increase threshold. So this is all plotted out to 42. So everywhere inside of this contour is where the level would be 6 or more above the background. And what this is showing is that there aren't any houses inside of the 6. contour.
Stop and give me compute. The blue line is 42?
Now, it's hard to see, but this outer contour line here.
Looks to be
this is
50.
Well, this one right here is 42. It's like kind of a maroonish line.
Well, I'm having trouble reading your one.
Yeah, it's hard to see.
The scale says 50.
That's this red line here. The little red circle, that's 50.
Okay, I'm sorry.
Yeah, no,
I just couldn't.
don't worry about that. But yeah, it's 50, 45 is the blue, and 42 is the outer contour here. So we just cut it off there so it makes it visible where the 6 threshold is. But
So what you're saying in this map is that based on your data, there is no impact in any house
well, I would say that.
on your modeling scale.
Yeah, well, what this says is that this project would comply with the DEC guidelines, and that's highly unusual. That's highly unusual. We've done maybe 30 projects in New York, and this is the only one, besides one other one, where this was the case. Every other one, there's many houses that are inside the 6 threshold. Many, sometimes hundreds, sometimes all the houses. And the only other one that wasn't, that did kind of meet the guidelines was a project that was on a huge piece of private land where nobody lived. And that, no problem there. But for this type of a project, highly unusual that it actually meets the guidelines. It's the only one I know of. Now, and this is at the 6 meter per second critical design conditions. Now, if we were to model at 7, this is when the turbine reaches its maximum sound power output. But at 7 meters per second, the background's slightly different, slightly higher. So the threshold, the 6th threshold would be 44, or it would shrink a little bit. You see, this is even smaller than the last slide. That's the rationale for using that 6 and finding the critical conditions for mapping and assessment purposes. I just show this for information, but it's the 6 meter per second plot that's the key.
Would you go back to that slide, please?
Yeah. Yeah. So this is the one where the outer or the threshold would extend the furthest out from the turbines. So the model results say that it's going to make it at all the houses. Now, just because it meets the guideline here, that does not mean the project's going to be inaudible and nobody's going to be disturbed. That is not the case. The project is going to be pretty clearly audible over most of the site area. It's just going to happen to comply with what the DEC suggests is a reasonable threshold. But the turbine should be pretty audible out to very roughly 2,000 feet. So that goes way beyond the 6 dBA threshold. So definitely audible, probably over most of the site area. I don't think it's going to be significant beyond about where 12B goes along the river. I think beyond that it'll be pretty low. And this is the mean level. Now turbines, the sound level varies with wind and weather conditions and time of day. There's no question about that. In particular at night, the wind tends to blow up above while it's calm near the ground. And it's got the curvature of the